Welcome back. In this video, we're going to be working on the second type of chi-squared test, test for independence. So remember last time, or actually in the last two videos, we were working on the goodness of fit test. And the reason it's called the goodness of fit test is because we're testing whether our actual data, let's say it's coin flips, heads versus tails, we're saying, how well does that fit our null hypothesis, all right? And maybe that's not our null hypothesis. Maybe our null hypothesis is male versus female, 67% and 33%, all right? What we're asking is, how well does our observed data fit our expected data, all right? That's why it's called the goodness of fit test. So how well do our data fit our null hypothesis? And those null hypotheses are either even odds, like I saw above, or based on previously known odds, like we saw with males and females, okay? Now, the second type of test we're going to do is a test for independence. And this is a little bit different than the goodness of fit test. In a test for independence, we're actually not going to be testing only one variable. Now we're going to be testing two different variables at the same time. Now, notably, this isn't the first time we've ever done this. In fact, several times throughout the semester, we've hit on tests that investigate multiple variables at the same time and how they're related to each other. One of them we just went over last week. It was correlation, okay? Correlations test the relationship between two continuous variables. Remember, one correlation we looked at a lot was age versus weight. All right, and there was a pretty decently strong positive correlation between those two. But notably, they're both continuous, meaning you can be anywhere along this point for age and anywhere along this point for weight. Next, we had t-tests and one-way ANOVAs. Now, these are a little bit different from correlation. With t-tests and one-way ANOVAs, we start with a categorical independent variable. All right, we split our participants into groups, either two groups for t-tests or three or more groups for one-way ANOVAs. And then we asked, does that IV impact our DV? Okay. So there's really two different situations under which we might use a correlation or a t-test or one-way ANOVA, all right? And it's dependent on what kind of variables we have. Here, we've got two continuous variables for correlation. For t-test and one-way ANOVA, we've got a categorical variable and a continuous variable, all right? And our graphs end up looking something like this, all right? Where you're comparing level 1 to level 2, okay, on our DV, all right? Now, in a test for independence, we're actually going to be testing the relationship between two categorical variables. So this is not like what we've done before. There are no continuous variables here, okay? So let's take an example. Is a person's religion related to their political party? Now, the reason we might use a test for independence here is because we've got two different variables, religion and political party, and they're not continuous, all right? For political party, it's just nominal. Which one do you belong to? Maybe you're a Republican, Democrat, Green Party, I don't know. There's a bunch of political parties. You could be an independent, libertarian. I don't know if libertarian counts as a political party, but. And religion works the same way. You could be Christian, you could be Muslim, you could be Catholic, you could be Jewish, you could be an atheist, you could be Hindi. There's really a bunch of things you could be, but they're all different from each other. It's not like they work in a line. They're not continuous variables. So I want to compare religious people's and atheist political affiliation. Okay, so now I'm getting a little bit more specific. I'm specifically comparing religious people versus atheists. all right? So I'm gonna really focus in on only a little 2 by 2 space, okay? So over here on the left, I've got religious versus atheist, and up top, I've got Democrat versus Republican, okay? Now, you'll notice again that both of these are categorical, so we're not gonna have like a large numerical variable there. So we can't calculate the average score of a person's religion. We can't calculate the average political party for all the people in a group. You just can't do it because it doesn't make sense to have an average, right? So what are we going to do for our null hypothesis then? Well, we're looking for a relationship between two variables. And remember, broadly speaking, our null hypothesis is commonly that basically there's no effect, all right? Uh, the mean of our group 1 is equal to mean of group 2. There's no difference between them, all right? So those are our old hypotheses. Here, our null hypothesis is there's no relationship between the two variables. Your religiosity does not impact your political orientation, all right? So, for our example, this would mean religion and politics are not related to each other. In other words, knowing a person's religion does not help you predict their political party. But if they are related, then if you know what somebody's religion is, you might be able to guess what their political party is, okay? Now, I want you to ask yourself, do you think this is true? Do you think religion and political affiliation are related to each other? All right. I made these data, and I personally do think they're related to each other. I would like it if we could all maybe talk to each other and discuss, but I do think there's a relationship between these two, at least based on personal experience. All right, and also based on my knowledge of research. Okay, so let's think about religion and political parties. Like with the goodness of fit test, we will compare expected frequencies to our observed frequencies. Okay, so it's pretty similar. Now, observed frequencies are really easy. Just like last time, you simply write down your observed frequencies. All right. So we simply ask people if they're religious and which party they belong to. So I put a little FO over here to indicate that these are our observed frequencies. Now, I went out and surveyed 50 people. I didn't actually do this. Let's just pretend I did this. And here are our observed frequencies. We got 11 religious Democrats, 14 atheist Democrats, 19 religious Republicans, and 6 atheist Republicans. So these are our observed frequencies, all right? They're what we found out there. What's next? Well, how many religious people are in our sample? How many religious people are in our sample? Well, if we want to know that, then clearly here we're only asking about one variable. We're not asking about Democrat versus Republican. So I'm going to add these two up, and I get 30. 11 plus 19 equals 30. How many atheists? Well, that'll be 14 plus 6 equals 20. Okay? So 30 and 20. And we can use the same thing to find out how many Democrats we have and how many Republicans we have. All right? So I've got 30 religious people, 20 atheists, and an even split between Democrats and Republicans. Now, what we're going to do is use these overall frequencies to determine our expected values, all right? Now, remember, expected means that's what we think is going to happen based on the null hypothesis. So the first thing we're going to do is get rid of our observed values, okay? So how are we going to find our expected frequencies? All right, so we're going to have frequency expected up here. Now, last time, we just put an even split. So maybe we should do 1/4, 1/4, 1/4, and 1/4. That seems reasonable, right? Well, the problem with that is if we do that, we're going to end up with 12.5 in every section. Okay, that seems all right. But the big problem here is this is impossible. We can't have 12.5 atheist Democrats and 12.5 atheist Republicans because we only had 20 atheists in the sample, okay? So instead, what we're going to do is we're going to use this formula, okay? Now, this formula looks a little bit complicated, but really it's pretty simple. We're just going to take these proportions, all right? We're going to take these proportions and apply them here, okay? And in fact, it might even be easier to go the opposite way. So we have a 50-50 split between Democrats and Republicans, and we've got 20 atheists. So 10 and 10. Same thing for religious people. We've got 30 religious people and a 50-50 split between Democrats and Republicans. So we just do 10, 10, 15, 15, all right? Now, that's relatively easy in this example, but I still want to show you this formula because I want to prove to you that that's basically the same thing, but sometimes it'll get more complicated than the numbers we have here. So FC and FR, all right? So FC refers to frequency of the column, and then FR refers to frequency of the row. So we've got columns up here and rows over here. So for Democrat religious, we have FC, which is frequency of the column, so 25, multiplied by FR. So that's 30, divided by N, which is 50 total participants. All right. 25 times 30, actually, let's go like that. That cancels there. And then 25 divided by 5 is 5. So we get left with 15 times 3, or rather 5 times 3. So we get left with 5 times 3, and we end up with 15. All right, exactly the same number as we found before. The same calculations will go for Republican. It'll be a little different for atheists. So frequency of the column for atheists is again 25, multiplied by the frequency for the row, 20, divided by the total, 50. Again, the 10 cancels there, the 5 cancels here, and we get left with 5 times 2 equals 10. Same calculations for Republican atheists, okay? So we end up with the same values because basically what we're doing is just applying this frequency over there. That's all we're doing, okay? The formula I know is a little bit complicated, but I hope this helps you understand really what we're doing. All right, so here's the same calculations that we just did. And we end up with 15 and 15 for religious, 10 and 10 for atheists. These are the values we would get if your religion had nothing to do with your political affiliation, okay? Here, if we know you're atheist, that doesn't help us figure out whether you're Democrat or Republican. You have equal likelihood being Democrat or Republican, all right? The same thing is true if we work the other way. So if you're a Democrat, that doesn't help us figure out whether you're religious or atheist. Now, it may look like it does because there's more religious Democrats than atheist Democrats. But the only reason that's true is because there's just more religious people overall, okay? So that's why this may look like there's a relationship, but there actually isn't, all right? So these values are the values we would have obtained if religion was completely unrelated to political parties. And that's our null hypothesis. So our frequency expected, just like last time, is just our null hypothesis frequencies, okay? So now we've got our observed frequencies, we calculated our expected frequencies, and we can use the same chi-squared formula that we used from the previous test, okay? So there it is right there. All right, and what we'll do is we'll start with each combination. So we'll start with Democrat religious, and then we could either go Democrat atheist or Republican religious, and then Republican atheist, okay? So we're gonna do 4 different additions. Now, this is a good time for you to go ahead and pause your video, go check it out for yourself, see if you can find the answer here. All right, let's get to it. So we start with Democrat religious, or I'm going to start with Democrat religious. Really, you can go in any order. So observed is 11 minus 15 squared over 15. Because we have 15 on the expected for both religious groups, I'm going to do religious twice first. So next I'll work with Republican religious. So 19 is my observed frequency minus 15 for my expected frequency divided by 15. Next, I'll move to atheist Democrats. I have a 14 observed frequency minus 10 squared over 10. And finally, 6 minus 10 squared over 10. All right, so let's figure that out. 11 minus 15, oh, these are all gonna have the same calculation. It's gonna be pretty easy to do this one. We got lucky. 11 minus 15 is 4, well, negative 4. Squared makes it 16 over 15. Plus 19 minus 15, again 4. 16 over 15. 14 minus 10, again 4. 16 over 10 this time. And again, we have a difference of 4, so that'll be 16 over 10. Okay, so we're gonna have to add these together somehow. If you've got a calculator, you can do that. But the way we wanna do this is to find a lowest common denominator. It's been a while since I've done this kind of math, so let's see how good I am. I think 30 is a good common denominator for the bottom. We can multiply these by 2 and these by 3. Yeah, that seems like the best one to me. So we have 32 over 30 plus 32 over 30. Now this time we're multiplying by 3, so that's 48 over 30 plus 48 over 30. Okay, so 32 plus 32 plus 48 plus 48. Man, I wish we were in class so I could ask you guys to calculate this for me. 3 plus 3 plus 4 is 10, so that's 100, plus 40. 2 plus 8 is 10, 2 plus 8 is 10, so 160 over 30. Zeros cancel, 16 over 3 is 5.33. Okay, so we get our chi-squared value of 5.333. Great, so we got our chi-squared of 5.333. Now, unfortunately, we can't yet answer this question, is this significant? All right, we're gonna need to know our degrees of freedom. But things are a little bit more complicated than they were last time, okay? Because for this test, we have to consider 2 variables at the same time, not just one, all right? So in the goodness of fit test, how did we find degrees of freedom? Do you remember? How did we do it? It was C minus 1, all right? The number of categories minus 1. Well, because we've got two variables, we've got two separate sets of categories. We've got two categories for religion and two categories for politics, okay? So we're going to use two calculations here. R minus 1 means the number of rows minus 1, and C minus 1 means the number of columns minus 1. All right, so we have two rows, religious and atheist, and we have two columns, Democrat and Republican. So we do 2 minus 1, which is just 1, times 2 minus 1 again, which is just 1, and that gives us a final answer of 1. Let's go check out our critical value. Again, we want to focus on the 0.05 column over here on the far right, and we're going to use degrees of freedom of 1. So that just gets us 3.841 one more time. Okay, so our chi-squared critical value is 3.841. Now, because our chi-squared value is finally beyond the critical value, so it's more extreme than the critical value, we get to reject the null hypothesis. Yay! So what does that mean? These variables do indeed seem to be related to each other, all right? And the way that they're related to each other is atheists are more likely to be Democrats than religious people. And the way that we know that is we can compare this to the expected frequencies, all right? For Democrats, there are more atheists than expected and less religious people. And the opposite was true for Republicans. There were less atheists than expected and more religious people than expected, okay? So another way of saying this is religious people are more likely to be Republicans than atheists, all right? So what did we find? You ran your study, you did a study on religion and politics, you go talk to your friend about it. What do you tell your friend that you found? All right, in fact, I want you to try it. I want you to say something out loud. We found that, blah. Say something, all right? Go ahead and try it. Pause the video and say something out loud. I feel like I did a pretty good job looking like I was paused, just in case you didn't pause it. So in our real description, like verbally you may have said it a little bit differently than this, but in our description that we would use to convey this through a manuscript, we, like always, start with the test, chi-squared test for independence, to test whether religious people and atheists differ in their political makeup, okay? So those are two variables that we're interested in. This test revealed that atheists are more likely to be Democrats than religious people. Now that last part could have been something you decided to say to your friend. Atheists are more likely to be Democrats than religious people. And by extension, atheists are less likely to be Republicans than religious people. Basically, you're saying the same thing, okay? So chi-squared with degrees of freedom 1 and n equals 50 is 5.333. So that's our chi-squared value. And what is our p-value here? What do you think our p-value is? We've come a long way, and I'm not going to ask you this question one more time until the final exam. So hopefully you know that this p-value, because we did find a significant effect, this p-value is less than 0.05. That means there's less than a 5% chance of finding a chi-squared value like this if there actually is no relationship between a person's religion and their politics, okay? So that's all for video 4. We talked about our test for independence, and we introduced a new way of calculating degrees of freedom, which is number of rows minus 1 and number of columns minus 1, okay? So basically like categories minus 1, categories minus 1. It's basically the way to think about it, all right? So that's all for this video. Next time, we're just gonna review a few concepts from the entire class, really. All right, I'll see you then.